This is MEC 19 braking systems. First I'll do an overview of the systems that we're going to be talking about for the operational description. First thing we'll talk about is the vacuum booster right here, and then we'll talk about the master cylinder, and we'll also talk about the disc brakes and drum brakes assembly. So let's start with the vacuum booster. Vacuum booster is right here. The vacuum booster uses vacuum created from your engine running. So on the intake stroke, the piston moves down in the cylinder, creating a vacuum, sucking air in through the intake valve. This causes air rushing past some small holes in the intake manifold, creating a vacuum. And the vacuum is represented by red here in this picture. We're going to change it to blue. So this blue part here is vacuum, right in here, that I'm coloring blue. Now, when the engine's running, vacuum is created on that side. At the same time, vacuum is on this side too. So that means that we have vacuum on the back side of this diaphragm and on the front side of the diaphragm. The diaphragm sits here like this, goes all the way up and stops right there. So you have two sides of the diaphragm. When the engine's running and your foot is off the brake, there is vacuum on both sides of the diaphragm. When you apply pressure to the brake, that pushes the pedal this way and pushes this rod forward. When it pushes that rod forward, it closes a little valve to keep vacuum from going into the back side of the diaphragm. We have vacuum on the front. We have atmospheric pressure from inside the cab comes in the back. Because we have a pressure differential, that causes this whole diaphragm to move in that direction, assisting our foot pedal and the pressure we take. And that sends pressure to the master cylinder. When we take our foot off the brake pedal, then this little rod moves back and the valve closes the atmospheric pressure from coming into the backside and allows atmospheric pressure to come to both sides. Because we have the same pressure on both sides, this additional spring will push it back, and then we have pressure coming off of the master cylinder. So that's the vacuum booster. Now we'll talk about the master cylinder. So you can see that this is the push rod pushing in from the vacuum booster. And as we put pressure on the vacuum booster, we have two circuits. We have primary circuit, which is at the front here, and we have the secondary circuit. You can see that there's springs inside here, and this part here and this part, these are the pistons. We have the springs. We also have these lip seals right here. Those lip seals actually expand when you put pressure on the hydraulic system. So, secondary circuits at the back, primary circuits at the front. When we put pressure on the brake pedal, then it goes through the vacuum booster and pressure is pushed onto these pistons and makes these seals expand and push out against the inside of the bore of the master cylinder. You can see that this spring here is weaker than this spring here. And so initially this whole piece here all the way through pushes that way, puts pressure that way. We know from hydraulics that liquids can either be compressed, can't be compressed. And so, because they can't be compressed, it puts pressure on that liquid. So this whole thing moves in that direction, puts pressure in this pink area down to typically your disc brakes or your front brakes. At the same time, pressure is being sent through to your back brakes too, because this lip seal is pushing the pressure down here. Now, how does the liquid from this side not go to that side? We have a backwards lip seal that keeps the green in the green and the pink in the pink. So now we have pressure going through the master cylinder. Pressure goes out to the brakes. When we release the brake pedal, then the springs push back. When the springs push back, the lip seal collapses. When the lip seal collapses, then fluid from this side, which has come in from the reservoir can leak past internally, which it's supposed to do, can slip past the seal and to fill up any excessive space on that side, on the pressure side of the seal. And the same thing happens for your secondary circuit. When you bring the pedal back, fluid from this side of the piston can leak past or slip past there and fill up any space if you need some more liquid because your brakes are wearing out. So where does it go from the master cylinder? Well, typically the primary circuit will send you to disc brakes. So you have fluid flowing in here, and as it flows into here, we have this green thing is called the caliper. The caliper has a piston in it, and that is the red part here, and you can see the fluid, it's blue, and it slides right in the back there. When we put pressure from the master cylinder onto the liquid, pressure gets sent in all directions, everywhere, and even to the back side of the piston, and it pushes the piston in that direction. We're just going to change colors a little bit. It pushes the piston in that direction. When the piston moves in that direction, this pad right here pushes up against our rotor. As soon as that pad is done pushing up against the rotor, then the whole caliper slides over so that this pad can push up against that side of the rotor. And so this rotor is spinning with the wheel, and as soon as you put pressure from the brake pedal, it puts pressure through to the back side of the piston. The piston pushes on this side, which sucks the other side of the caliper over and creating friction on the disc and slowing your vehicle down. This is the front discs. Now we'll go to the back discs, the back drums I should say. How do they work? Well, the cylinder here is called the wheel cylinder or the brake cylinder. And if we could go from the back of this backing plate, you would see that there would be a line supplying pressure right there in the middle between the two pistons. When we put pressure from the master cylinder, comes into the back side of the inside of the brake cylinder, pushes out on the pistons. That puts pressure out this way on the pistons. Because of that, the shoes here push hard against the inside of the drum. The drum is on the outside, and it is spinning whenever the wheel is turning. So those shoes, as they push back here and here, put pressure and therefore friction on the inside of the drum, causing the vehicle to stop. When you take your foot off the brake pedal, then those shoes retract because we have these springs here to pull the shoes back. As you are applying the brakes in reverse, typically what happens is this star wheel adjuster, this little yellow lever has to move up and down, and it clicks this star wheel adjuster so it expands the brake shoes so that they stay close to the drum. One of the things that I forgot to mention on the disc brakes was what happens when we release the brake pedal. So you've put pressure onto the back side of the piston through the liquid. As soon as you release the brake pedal, then pressure comes off, and there's a square cut seal that sits just inside on the piston that just slightly sucks the piston back.